Okay, we have an interesting question here under simple harmonic motion, and it says a simple pendulum with a period of 2 seconds has its length doubled. Its new period is, and we're now giving some options here. So, but let's first write out the formula for calculating the period of a simple pendulum, and let's see if this period will be connected to the length of the pendulum. So, writing out the formula, we will know that the period t equals 2 pi times the square root of the length of the pendulum over the square root of the acceleration due to gravity. Don't forget, this is the length of the pendulum, and this is the period of the pendulum, and this is the acceleration due to gravity. So we could now further simplify by rewriting this as, say, period equals 2 pi times the square root of the length of the pendulum divided by the square root of the acceleration due to gravity. So this is acceptable. So this has now become this following law of indices. So it's okay. So from this alone, we could tell now that following horizontal test, that the period is directly proportional to the square root of the length of the pendulum. So writing that out, we will have that t, the period, is proportional or directly proportional to the square root of the length of the pendulum. And we now have to write it as an equation by introducing the constant k. So writing as an equation, we are going to introduce the constant k. It now becomes t equals k times the square root of the length of the pendulum. Then we will now have to make this k the subject of the formula. So we divide through by root L. So dividing through by root L, we'll have root L cancels root L. We have k here alone, and the k is now equal to the whole period divided by the square root of the length of the pendulum. So let me write that out well. So we now say k equals to the period divided by the square root of the length of the pendulum. So now that we know that this is constant now, because the constant value has given us this, so we're going to duplicate this now since we know it's constant. So duplicating it, we're going to have, so from this we'll have a new duplicated formula. We'll have t1 over root L1 equals t2 over root L2. So this is what we need to solve that particular question. So this actually connects the period and the length of the pendulum, just like how the original formula connects the length of the pendulum and the period. So going back to that question, we could now use that new formula we just derived. We will now say that t1 over root L1 equals t2 over root L2. So from the question, what is our t1? So we have said a simple pendulum with a period of 2 seconds. That's our t1. That's the first time, t1. So we're going to say t1 equals 2 seconds. Then the next thing is to check is our L1. So what's our L1? Anyway, but they said if you've really digested the question, they said that a simple pendulum with a period of 2 seconds has its length doubled. That means before it was doubled, it was just L. So that means the L1 is just L. And then the L2 will now be the doubled one. So we'll now say L2 will now be 2L, since they said it's doubled. Then the T2 will be what we are looking for, question mark, according to the question, because they said its new period is, and the period is always T, and that will be T2, since we know T1 is 2 seconds. So that's all we need. We could just substitute into the formula and we do our abracadabra. So looking at this formula now, we'll fix our T1 and L1 and L2, and that's all. So for the L1 it's 2 seconds. Let's just fix it there. So 2 seconds, 2, that's 2 over root, what's the L1? The L1 is L from this table here. L1 is L, equals, the T2 is what we're looking for, over root, the L2 is now 2L, that's 2L. Then we'll cross multiply and make our T2 the subject of the formula, because that's what we're asked to find. So we'll cross multiply. So we have T2 times root L gives us T2 root L equals, then we have 2 times root 2L gives us 2 root 2L. Then we could break this one down. We could further simplify this. So we will now rewrite the whole thing as T2 root L equals 2 times root 2 times root L. So breaking it down this way, remember it's possible following law of indices, this can become this, so it's possible. So now that I've made it look more simplified, we can now say root L cancels root L. Then we have just this and this. So we now have T2 equals 2 times root 2 is 2 root 2, 2 root 2. So our period, our T2 is actually 2 root 2. But what is 2 root 2? If you use your calculator and you multiply this, you find out that our period will now be T2 is equal to 2.83, approximately 2.83 seconds. So this would give this if you punch it into your calculator. So the final answer is 2.83. So let's see the particular option that it belongs to. So 2.83, and that is option D. So that's it. Very simple and very easy.